Maths channel. I'm now going to be answering question number 9 from the Pure Mathematics P3 October 2022 International A-Level exam from Edexcel. This question here is about trig identities and equations. Now, part A is asking us to prove that cosine squared theta over cosine 2 theta minus sine 3 theta is going to give you this. It simplifies to this 1 plus sine theta over 1 minus 2 sine theta minus 4 sine squared theta. And they've also said, given that cosine 2 theta minus sine 3 theta does not equal 0. Okay, so now what we have to do here is we have to rewrite this to write it in that form. I think it's much easier to go this way here, okay, rather than the opposite. So let's make a start here. Now, first of all, I notice one of the things when you're doing these type of trig identity kind of proofs, there's a few points that you should keep in mind. Okay, it's not just random. How you go about doing it. It's random stuff like you think, oh, how did you get from there to there? Just no. You think there's some sort of logic behind it, although you cannot see the whole picture in front of you. You don't see the whole journey, every footstep that you're going to take in front of you. You've got a general idea of what you're going to do before you start. So, for example, I see that this answer that I've got here, what we have to show, doesn't have any cosines in it whatsoever. It's all in terms of the sine ratio, sine squared and sine whatever. Okay, so that's one thing. So I can notice here the cosine squared theta, cosine 2 theta, I'm going to have to rewrite them in terms of sine. And we know that one of the most important fundamental identities is that the cosine squared theta plus sine squared theta plus cosine squared theta equals 1. If you take the sine of an angle and you square that whole thing, and you take the cosine of an angle and you square that whole ratio, and you add them together, you're always going to get 1. So the cosine squared theta can be replaced with 1 minus sine squared theta. So that's the first step I think I'll take. I'll say that that cosine of 2 theta over cosine squared theta. Start again. Cosine squared theta over cosine 2 theta minus sine 3 theta. So the first step, I'll write this as 1 minus sine squared theta on the numerator. Okay, that's the first step. Secondly, cosine 2 theta. That's the double angle formula that we're going to know. Now, this is not given to you in the formula book. Neither is that anyway. So cosine 2 theta, the double angle formula, we need to know those formula. And they're based upon the addition formula, which is the cosine of A plus B equals, now this is in the formula, but cosine A times cosine B minus the sine of A times the sine of B. It's based upon this, where you just basically call this cosine theta plus theta. Okay, so you call this cosine of theta plus theta. That's cosine 2 theta. So you get cosine theta times cosine theta, which is cosine squared theta, minus sine theta times sine theta, which is sine squared theta. So this gives you cosine squared theta minus sine squared theta. That can be derived from the addition formula if you need to, if you forget it. Right, but you shouldn't forget it. You should know these. Now, as I said, I want to rewrite this in terms of just sine squared theta. So I don't want to have any cosines in here because that's how our answer looks. So what I'm going to do is I'm going to rewrite cosine squared theta as 1 minus sine squared theta. So I have 1 minus sine squared theta minus another sine squared theta. That's 1 minus 2 sine squared theta. So that's another identity that you should know, that cosine 2 theta is equal to 1 minus 2 sine squared theta. Very important that you know that identity. So I can replace cosine 2 theta with 1 minus 2 sine squared theta. So that's, starting to look a bit more similar to this in terms of we've got rid of the cosine so far. Now, sine 3 theta, how do I deal with that? Well, we can't really deal with that apart from splitting it up into a double angle. So we're going to call it sine 2 theta plus theta. that will help us to split this up into something where we're going to get rid of the double angle. So basically, we notice that all of these are single angles, so we got to get rid of the double angles. And all of these are involving the sine ratio, so we got to change all the cosines to sines. So far, so good. But this now, I have to split this up. Now, we're going to use, again, the double angle formula. I know that the sine of A plus B is in the formula book. We got the sine of A times the cosine of B plus the cosine of A times the sine of B. That's how that splits up. So what we're going to have here now is going to be, we're going to have 1 minus sine squared theta. And I noticed that my answer has to have 1 plus sine theta. So I'm kind of guessing this is going to be 1 plus sine theta as a difference of squares times 1 minus sine theta. Kind of getting ready for that. Hopefully the 1 minus sine theta will be cancelled out in the end. Okay, so now we're going to have here, this is 1 minus 2 sine squared theta. Those two are fine so far. Okay, but this now, I'm going to have minus. Now I'm going to put a bracket to protect what I expand here using the double angle formula, using the addition formula. So this is going to be the sine of the first angle times the cosine of the second angle. So this is sine of 2 theta times the cosine of theta plus, and then you're going to have the cosine of the first angle. So cosine of 2 theta times the sine of the second angle. Okay, so that's as far as we got. Now, again, I want to get rid of the double angles. So this so far, what we got here on the top is fine. 1 plus sine theta, 1 minus sine theta. We're hoping that this will be cancelled out eventually, the 1 minus sine theta part. We have 1 minus 2 sine squared theta. That's how we want it for now. Now, what we're going to do here is I'm going to, first of all, I'm going to expand this to get rid of the this bracket. So we have minus sine 2 theta cosine theta, minus and plus is minus. You've got to be very careful about these signs. That's why I'm doing this now, so that I don't mess up later on. Okay, so I'm just getting rid of that bracket so that I've got these signs sorted out. Now 1 plus sine theta times 1 minus sine theta over, here I have 1 minus 2 sine squared theta. Now, I know that sine 2 theta is the same, that's again using the double angle formula, that's the same as 2 sine theta cosine theta. And the reason being, for this reason, if I call this theta plus theta, I have sine theta cosine theta, and I have cosine theta sine theta, and I add them together, I get 2 sine theta cosine theta. That's using the double angle formula. That's something that we should have memorized. It's not in the formula book again. So this is going to give me minus, and this will be 2 sine theta times cosine theta times another cosine theta. So that's going to be 2 sine theta cosine squared theta, because when I replace the sine 2 theta with this, I'm going to have a cosine theta times another cosine theta. I just wrote that down to save me an extra line. And then we've got our cosine, we got here, this is like sine theta multiplied by cosine 2 theta, which we already mentioned is the same as 1 minus 2 sine squared theta. Okay, so that's sine theta times 1 minus 2 sine squared theta. Okay, so now we're going to have here, again, 1 plus sine theta, which we want to keep, 1 minus sine theta, which hopefully this will cancel out, over. Now, this is, okay, I can replace this again. Okay, so let's just 1 minus 2 sine squared theta. That's so far so good. Minus 2 sine theta. What I'm going to do now is I'm going to write this as cosine squared theta as 1 minus sine squared theta. Remember, we want to get rid of all the cosines. So cosine squared theta can be rewritten as 1 minus sine squared theta. And then I'm going to expand this. So I have minus sine theta. Minus times minus is plus 2 sine. I've got a cube theta here. Okay, it's looking a bit complicated, but hopefully it will work out. We've seemed to have done everything right. I've kept this, I've made a copy down here so I can see what I have to end up with in the end. Okay, I don't like the fact there's a cubed here, but we'll see what happens. So we have 1 plus sine theta, 1 minus sine theta. Okay, that's the 1 plus sine theta from up here. That's so far, for that, that's okay. Over. Oops. Okay, so I have 1 minus 2 sine squared theta. Nothing can cancel so far, so let's just write this out. 1 minus 2 sine squared theta minus 2 sine theta. Okay, plus 2 sine another cubed theta minus sine theta plus 2 sine cubed theta. All right, so now let's just simplify and let's see what happens next. Okay, we can combine like terms. There's nothing like 1, there's only constant there. 2 sine squared theta. Okay, so you got minus 2 sine squared theta. That's only sine squared theta. Then you've got minus 2 sine theta minus sine theta. That's minus 3 sine theta. Okay, and then we've got 2 sine squared theta plus that's 4 sine cubed theta. So that's what we've got, and that's what I have to look like in the end. Okay, what I'm going to do here is to keep this in like some sort of order. I'll write this as minus 3 sine theta minus 2 sine squared theta. So I'll write this as, this will be a 2 here. Just swapping them around so that it's more kind of in order. And this was minus 3 sine theta. Okay, so that's minus 3 sine theta and minus 2 sine squared theta. Okay, that's what you have, a minus 3 sine theta and minus 2 sine squared theta, and you've got plus 4 sine cubed theta. All right, so how does this become that? Well, I'm guessing here. I think the only way we can deal with this, because basically, if we have to think about factorizing this, okay, I'm thinking that one of the factors of it must be 1 minus sine theta. If we've done everything correctly, it should work out. So I'm going to write this as 1 plus sine theta times 1 minus sine theta. So one of the factors, if this becomes that, then this will factorize into one factor as 1 minus sine theta for sure. And that will be multiplied by something that gives us this. Now, obviously, if those cancelled out, what should be left is what we have in this bracket, what we have in this denominator, which is 1 minus 2 sine theta minus 4 sine squared theta. That's what must come up. All right. So here we're not actually factorizing. We're using the fact that we have this given in the answer, and we're using the fact that we have to be left with 1 plus sine theta. So for this to become that should have a 1 minus sine theta as a factor, and we should be left with this at the end. So we're gonna verify that this actually does give us, when you expand it, it gives us, when you expand this, it gives us that. If this expands to give us that, then this is the factorization of that. So let's see, we have 1 times 1, which is 1, that's fine. You have minus 2 sine theta, and you have minus 4 sine squared theta. So let's just write it over here just to make sure. So you have 1 times 1, which is 1, and you have minus 2 sine theta, then you have minus 4 sine squared theta. Okay, then you have minus sine theta, and then you have plus 2 sine squared theta. Then you have plus 4 sine cubed theta, plus 4 sine cubed theta. Now, does that simplify to this? Well, you have minus 2 sine theta minus sine theta. That gives you minus 3 sine theta. That's fine. And then you have minus 4 sine squared theta plus 2 sine squared theta. That gives us that. That's fine. And yes, so we verified that this is, the same as this thing factorized. Okay, and how did we do it? We didn't actually have to factorize this. This is a cubic. It's difficult to factorize, not impossible, but it's going to take a long time, to try to factorize this using, say, the factor theorem. However, we use the fact that we know we have to be left with 1 plus sine theta, so the 1 minus sine theta must be cancelled out, so that should be one of the factors. And what we're left with in the answer should be this in the denominator. So that's what that should be. So that's a quick way now of completing the answer. So I'm going to get rid of this now. I just put that to check that it does actually give us what we need. So now, finally, we can write down the answer. It's quite a long one, this one. You have 1 plus sine theta over 1 minus 2 sine theta minus 4 sine squared theta. And we have completed this question. Okay, that's as required. Okay, so that's a pretty long. I think many people would have struggled with that one, especially at the end here when they got to this. But you got to use a bit of, brain, a bit of shortcut, a way of doing things. Think about, how we can use what they gave us to, get what we need. So we know that if this was going to be cancelled out, you must have a 1 minus sine theta in the denominator. And if they did cancel out, that's what you should be left with in your denominator. And you can verify that that gives you the expression that you got there. But you got to be very careful with your changing of, these things, and also the minus signs and the plus signs. And it's a very tricky type of question here, and it's quite long. So it's well worth the full marks. It takes a long time to get there. All right, so there's the answer to part A of this question. I wonder what the examiner's report says. I think that would have been one of the questions which students struggled with, especially with, time-wise. Okay, so now for part B. It says, hence solve for theta between 0 and 360 degrees. This equation here, cosine squared theta over cosine 2 theta minus sine 3 theta equals 2 cosec theta. So even if you kind of got stuck with A and you went halfway through it and then you couldn't finish it, whatever, all right, you still have 5 marks you can salvage from this question, and we can use what they gave us in part A. They told us to show that this becomes that, so we can use the fact that this can be replaced by 1 plus sine theta. Obviously, that's what we have to do because it says hence. So I'm going to replace this with this fraction here, 1 plus sine theta over 1 minus 2 sine theta minus 4 sine squared theta. Okay, and we want to make it equal to 2 cosec theta, which is the same as 2 over sine theta. I'm just going to write it so that it's like the same, everything in terms of sines, obviously. All right, so we know that cosec theta is a reciprocal function. Cosec theta is a reciprocal function for sine theta, right? So now what I'm going to do is I'm going to multiply both sides by sine theta and also by this, quadratic here to get rid of the fraction. So I have sine theta times 1 plus sine theta equals 2 times all of this. So I'll just, expand that as 2 times minus 4 sine theta minus 8 sine squared theta, and here we have sine theta plus sine squared theta equals all of that. So what we can do here now is we can think of this as a quadratic equation and bring all the terms on one side. So I'm going to add 8 sine squared theta to both sides. That gives me 9 sine squared theta. I'm going to add 4 sine theta to both sides. That gives me plus 5 sine theta. And I'm left with 2, so I'm going to subtract 2 from both sides. I have minus 2, and that's equal to 0. So the question says, give your answers to 1 decimal place. We got to solve this in degrees. All right, so now I'm going to first try to see if this thing factorizes. So what I'll do is to make, as we normally do, make things a bit less unfamiliar, make things familiar. Let's call sine theta, let's call it b, for example. So then I can replace this with b squared and this with 5b. And then I can solve it like a quadratic that we're used to. So I can say here that I'm going to factorize this. To factorize this, okay, I like to use this little method here. So I have 9b and minus 2. So let's see if it factorizes first. That gives me minus 18. That should be, minus 18b, that should be 9b squared, sorry. Minus 18b squared. These two numbers must multiply to give me minus 18b squared, but their sum has to be plus 5b. So let's think of all the ways of getting 18. We have 9 times 2, 18 times 1. We have 6 times 3. None of them has a difference of 5. Obviously, we can't factorize this. Okay, there's no way of getting a product of negative 18 and a sum of 5. So we're going to use the quadratic formula, or we could use completing the square. I think using the formula would be easier in this case. So we can say the values of b are, you're going to have minus 5 plus or minus the square root of the b squared. Now, the b I'm talking about now is the coefficients of these terms. All right, so it's going to be 25 minus 4 times 9 times minus 2 all over 2 times 9. Okay, that would be the, that will give us the values of b, which can end up being sine theta. So we can work out what those values are. If you write that down, that's enough for you to show your steps. Okay. In general, you should really show that you've used the quadratic formula. So minus 5 plus the square root of 25 b squared minus 4 times 9 times negative 2 all over 2 times 9, 2a. Okay, that gives us minus 5 plus root 97 over 18, minus 5 plus root 97 all over 18, and if we change this to a minus sign there, we'll get the other solution, which is probably going to be the same thing, but minus between them. Let's see. That gives us minus 5 minus, basically that's minus 5 minus root 97. That's what it is. Minus 5 minus root 97 all over 18. How is that the same? Some people might ask, because it's minus front of the whole fraction. It's like a bracket. So it's minus 5 minus root 97 over 18. Okay, it's the same thing as this, but just with a minus between them. So those are the two solutions for b. So we can say those are the two solutions for sine theta. So we can say sine theta is either minus 5 plus root 97 over 18, or sine theta is minus 5 minus root 97 over 18. Okay, so let's see what these give you. Now, this gives us minus 0.824, so that's a value we can use. Okay, and this gives us, both of them will give us solutions, actually. So I can use both of them for our solutions. The values are between minus 1 and 1, minus 1 and positive 1, so they will both give us solutions. So we got to find all the answers between 0 and 360 for this. Okay, so now we're going to say theta equals inverse sine of this, and for this, theta equals inverse sine of that, right? So let's take this one. Okay, so this is that one. So I'm going to press inverse sine. Okay, now, before I do that, I'm going to change it to degree mode, because we have to do degrees here. So now I'll do inverse sine, okay, of that answer. One second, let me just bring up the answer again. And with this one, so this equals, so inverse sine of the answer, okay, that will give us 15.627. 15.627, I'll write it to more places than I need. And then we know the other angle for sine is 180 minus this angle. Right? It's always like that with the sine. You get the main angle from the calculator and you do 180 minus that angle, and that gives you the other main angle, which is 164.373. 164.373. All the other angles will be outside of our range because we only need to go up to 360. Okay, as we can see here, we only go up to 360. Okay, it's got the equal sign there. I don't think we'll need it, but yeah. So if I add 360 to this, of course, it's going to be outside of the range. Same with this. If I take away 360 from these, of course, they're going to be outside of the range. So those are the two main angles by using this ratio. And then I can round them to 1 decimal place as required in the end. As I mentioned, 1 decimal place. For the next angle, I'm going to first, let's go back to that was this one, right? Minus in front of the whole thing. So that's, okay, that's our answer now. So I'm going to find inverse sine of the answer. Now, this is going to give me an angle which is negative. Okay, it's going to be negative 55.582. Negative 55.582. Now that is outside of our range. However, it doesn't mean there are no angles within our range that have this ratio. We've got to be very careful about this. Basically, what we've got here, in this case, what we had our sine curve going like this. Okay, our range is like in this region here. Our range is in this region here this is what our range was in. This region here between 0 and 360. And the calculator gave us the angle over here, which is a 15.672. And there's another place over here, which was 164.373, which has the same sine ratio. And that's because of the symmetry of the curve. This is 0. This is 180 degrees. And this length are the same. Okay, they're the same length. Okay, so this is 15.627 more than 0, and it's also 15.627 less than 180 because of symmetry. Now, in this case, what we've got here is we've got our sine curve going like this. Again, our range is the same range, okay, between 0 and 360, which is from there to there. But this time the calculator gave us an angle over here, minus 55.582. That's what the calculator gave us. But it doesn't mean that there's no solutions that have that same sine ratio. There's one here and there's one there. There's two solutions in our range which share the same sine ratio as this angle. And they're in our range. So what we have to do is we have to do the same thing as we did. What did we do to get the other angle? We did 180 minus the principal solution the calculator gave us. The same thing we do here. 180 minus, be careful about the sign, minus 55.582. So if I take the angle that I got from my calculator and I do 180 minus that answer, that will give me this angle over here. So you can see it's 55.5 more than 180. So it gave us, where was it going again? It gave us 235.582. So that's 235.582. And we notice there's another angle also in our range. And because the sine curve just repeats itself every 360, the sine curve is going up here. 360 degrees later, it's also going to go up here. So if I take this angle and I add 360 degrees to it, I'm going to get the angle over there. So I'm going to take the minus 55.582, which we don't accept as our answer because it's out of the range, but we're using it to find both these other two answers. So I'm going to take this answer, okay, which was my answer from before. Whoops, what did I do? Let's go back. Okay, so this answer, I'll just do it again. Inverse sine of the answer gave us, I've done something wrong, 1 second. Let me fix that. Okay, so this is our answer. Inverse sine answer equals. Okay, so I'm going to add 360 to this, and that gives me 304.417. So that's going to give me 304.417. Okay, so I added 360 to this. So I add 360 to this, and it gives me this angle over there. All right, so that gives me my solutions. I have 4 solutions, and I'm going to round them to one decimal place. 15.6 degrees, 164.4 degrees. Okay, and here I'm not going to write this answer down. I'm going to have 0.6 degrees and 304.4 degrees. Those are my 4 solutions, which are all within the range of 0 to 360, and I found them. Now it's very important for us to understand how to deal with this. For the sine curve, the main solution, 180 minus that solution. If the main solution is outside of our range, don't reject it straight away. Find out angles that could be in the range. 180 minus the main angle gives you the other angle, and then they repeat every 360 degrees. And there's your answer. If it was cosine, we would use the principal angle using the calculator, and then 360 minus that, because of the symmetry of the cosine curve is different. If it was tangent, it was just the main angle, and then all the other angles just separated from that by 180 degrees. Okay, so there we have it. The answer to question number 9. It's a pretty long question, actually, in both A and B. So I think it's a bit of a challenge for time in this particular paper, but it's doable. So I hope everyone understood that fine. Thank you for watching. Other questions from this particular paper can be found in the playlist that will be appearing in this region over here. Other questions from the topic of trig identities and equations from P3 in this playlist over here. You can subscribe to my channel by clicking on this link, and the link over here will take you to a video which tells you how to use my channel in an efficient manner. Thank you for watching and see you soon.